like to thank everyone for joining us this morning to the Reynolds Company's Tech Talk series. We do two of these a month, and today, March 24th, the topic will be HART and highly integrated HART. So we'd like to thank everybody for taking some time out of their morning to join us in our discussion. Okay. Today, will be two guest panelists. Myself, my name is David Newt, and I'm one of the automation specialists with the Reynolds Company in Houston. And I believe we will also have Justin Ryan joining as well. For those of you that don't know Justin, which is probably not many, Justin is a process and safety solution consultant for Rockwell Automation, has a very deep knowledge of technology, including HART technology. And I'd like to take a moment to thank Mike Masterson for my bouncy introduction there. Before we get started on the topic of the day, we want to take a quick time out to promote some of our future tech talks and user groups that are coming up around the corner. In April, we're going to have a session on Rockwell Automation software activation. That should be a good discussion. Talk about what's new, some changes, some updates, some of the new technologies, probably around Flexera and Code Meter. So that should be a good discussion, especially for system integrators that need to know the difference between the two and how to manage that. And then late April, we're going to have Win 911 join us to talk about alarm notifications and how that affects the IIoT technology space. That should be great. And then in May, we're going to talk about SIP safety over Ethernet IP. So that's something that's becoming a lot more utilized, especially in the machine control space. And so our tech talks are typically a little more focused and a little shorter, typically 30 minutes, maybe a little bit longer than that. And then we have our user groups, which started several years ago, and we tend to take a larger topic and take more time, maybe an hour and 15 minutes on the user group. And so in April, our topic, the user group topic is machine learning for AI, and AI for industrial applications. And then in May, we're going to have a machine safety versus process safety discussion, SIL versus PLE. So that should be really good. Clear up a lot of things there, because that's a topic that's easily stumbled upon. So with that, we're going to jump into HART today, and so we're going to really talk about two things. We're going to kind of talk a little bit about the HART itself, and some of the ways that Rockwell has kind of previously integrated HART and supported HART. And then the primary part of the discussion today, we want to talk about a new offering that Rockwell introduced last year in conjunction with PlantPAx 5.0, and that's something that's called Highly Integrated HART, and that's real excited about that. There's a lot of functionality and technology that Rockwell's put into that that makes it a lot easier to implement HART systems as a system. So we're excited about it, and so we'll go ahead and get started. So I think a lot of us have heard of HART. We've run into it in one way or another. HART's been around for a while. It stands for Highway Addressable Remote Transducer, for those of you that like to know what things stand for. So HART is, it's definitely a globally recognized standard. It was derived from some technology that was available in the 1980s, so it's been around a while. But it's a digital network communication that sits on top of your 4 to 20 milliamp signal. So we like to call that kind of a hybrid communication protocol. But one thing that it really helps it is because it sits on top of your 4 to 20 networks exist everywhere, and so it's very easy. It's a it's very easy to sit on top of the physical media because the 4 to 20 is so prevalent among analog communication. So it's an open source protocol, and so what that means is the protocol is open to any manufacturers that want to create a product, a device that will communicate with it. And so because of that, it has been widely adopted and probably considered the world's largest network, especially in the process network. There's, I read online that at least 30 million devices communicate over HART that have been installed, and then that's probably a low number. I would expect that to maybe even be a little bit higher. And so with the 4 to 20 signal, it actually communicates bidirectionally, meaning if you have an analog input 4 to 20, the HART communication actually goes both ways. So you can read and you can write data to an analog instrument, an analog input instrument. And so what kind of defines HART? There's sort of two aspects to HART. So the one that we probably are more familiar with is the reading of the process variables. But there's also a number of series of device commands that are out there that support HART protocol. And so any of you that have used a HART handheld device to configure a field device have used the device commands. And the device commands, just so you know, we're kind of divided into three levels. There's the universal command, and that's a requirement from HART protocol. And typically what a universal command is the reading of your process variables or your process data. We'll talk a little bit more about that. And then you have kind of common practice commands, meaning something that you would do on communicating to most of the field devices. So that would be something like maybe setting the range of the device, maybe configuring engineering units, something that's very much common practice, but maybe not 100% required by HART. And then you have your device specific commands. And so you've got, depending on the device, whether it's a field, whether it's a flow transmitter or a level transmitter, or maybe a totalizer or something else, you may have very specific device commands. And so those are also available to read and write over the HART protocol. And so kind of continuing on, well, how does it work and how does it put together? So there's kind of two modes that you can operate in a HART network. One is point to point. And so what that means essentially is you have one field device connected to one set of 4 to 20, one 4 to 20 current loop that goes to, that loop might connect to an analog input module on a controller. But there's one signal per loop. And so that's the point to point. And that's what we really see mostly in industry, and that for a lot of reasons, but there's also multi-drop available with HART. And so what happens on the multi-drop is the current loop is fixed at a 4 milliamp. And then each device that's connected to that multi-drop then communicates sort of one at a time, kind of in a daisy chain network architecture, similar to the way you would set up a Modbus RTU network. And then with the HART version 7, which I believe is one of the later versions of HART, you can support up to 64 devices on a single current loop. And we don't see that as much, especially here in Houston in the process industries, because you don't want to tie all your process devices, especially if you're doing control. You typically want to have a point-to-point HART network set up for that. And so a little bit of background on the technology. It uses frequency shift keying, which allows the digital network to impose itself on top of the 4 to 20 current. And so that was actually a telecom technology that was developed back in the 1980s that now is used all over process for HART. So So that's a little bit about the protocol and some background. And so how do you set up the network? Well, how do you configure the devices? So a HART, a device that supports the HART standard, that manufacturer will develop what's called a device description file, or in some cases you might see maybe called a DD file, maybe called an EDD file for electronic device description. So what that is essentially kind of a file that describes all the features and functions of the device. So all the variables that you want to get access to are encompassed in this electronic device description file. And then that file is used by the host system. So that file is used by Rockwell Automation to be able to get data, communicate to that device. And there's also another type of technology called the DTM, or the Device Type Manager. And so that is similar in that the DTM does also contain the device specific information, but the DTM is kind of an encompassed software component that runs. And so it's just a slightly different way of configuring or getting access to those HART devices, but that's essentially what we use. And so when we have a video and some other information today that we'll talk about how Rockwell interfaces to the DD files. And so with HART, so once we have the HART configured, what are we doing with it? Well, the way the HART protocol works is you have 4 what we call dynamic process variables. And so, and that you may see PV, SV, TV, and QV on systems. Those are the 4 different dynamic variables. And so, and they're dynamic because they're constantly being updated. They're on the network, and the device is producing those values if it's an input device. And so that's how we get the HART data out. Now there's also there's also quite a lot of other variables that are available in the HART protocol. And so, but you can only have 4 dynamic variables at a time. And so, so if you want to get to other configuration data or manufacturing information about that device, you use what's known as HART pass-through. And so with a HART pass-through, that allows systems, so that could be like a software system like Endress Hauser's Field Care, or that could be Studio 5000. HART pass-through allows systems to get access to more of the data and information that's available from that device, field device, over the HART protocol. And so you may have heard the term HART pass-through. And so that's kind of an additional support that we can offer to get more data than just the 4 dynamic process variables out of the HART device at a time. And so we'll talk a little bit more about HART pass-through. So before we go to the new technology, let's kind of reset ourselves with the way things have been up to this point before the PlantPAx 5.0 came out. And so the Flex IO, the 1794 HART modules have supported the dynamic HART variables and also HART pass-through for some time. And so let's just reset ourselves on how that works. So those of you that know class 1 data transfer is the primary way that an IO gets updated inside a Rockwell remote IO system. So class 1 data is the highest priority. It gets over Ethernet IP, and that's how the 1794 would update the controller. And so the HART modules support the 4 dynamic variables also in a class 1 data transfer. But if you wanted to get to more of the data and maybe do some maintenance or some ad hoc kind of messaging between your control system, your Studio 5000 and the device, you had to use, you would use HART pass-through. And with the 1794 modules, that was done via message instructions. And so for those of you that haven't used it, there's a 200-page manual on how to set that up. But essentially you're creating message instructions in a custom way to get to that HART pass-through data, although it is available. And in some control systems, they only support the 4 dynamic variables, and you're not able to do the HART pass-through. So that was a significant step when the 1794 HART modules came out and then supported HART pass-through. But now with the Studio 5000 modules, we've taken that a step further and eased the configuration significantly. So let's talk about the new technology for a little while. So these are the new HART modules that are Flex 5000. So I won't go into the details of the Flex 5000 itself. We've covered that on other calls. So what I really want to focus on is the highly integrated HART features. So there's a number of things that Rockwell has added, and then sort of we've kind of packaged it as the highly integrated HART. So the first thing that's important is the visible access to HART devices. And so inside Studio 5000 now, using the Flex 5000 modules, you are able inside the IO tree to view all your HART devices that are connected. And so there's a little screenshot there on the right that kind of just shows that. And so the other thing you can do is if you want to add a new device or change a device while you're online with the controller, we support that now as well in the IO tree. So we support auto discovery, and we've got a video in a few minutes that will show that shows that, and that's really a significant step forward. And so with that, there's an integrated new look and feel to how all that's done, and we'll see that in a video shortly. And so these HART modules came out fairly recently, and so you'll need at a minimum version 32 or later of Studio 5000 to use these modules. So let's move on. So some other aspects of the Flex 5000 modules. There's standard data structures per channel that are implemented that help, and also per channel you configure scaling and alarms, and the alarms supports the factory talk alarm and events, which was a big step forward that came out in the last several years. So now all your alarms can be configured in Studio 5000 inside the IO module. So you no longer need to use the ALMA or the ALMD alarm blocks in Logic, so you can free up some Logic space and configure and you do alarms in the IO setup. And then there's also a number of channel level diagnostics that are available in the HART Premier integration that's now available. So let's talk a little bit more about what we can see and in the HART integration. So we've got, so here is a screenshot of HART devices that you can see in the IO tree. And also to the right there is a process device tags that are available via the import of the DD file or the device description file that now you import and you use in Studio 5000. And also coming in future releases, there will be embedded device type managers and add-on profiles for particular process devices inside Studio 5000. So with that, I'm about to start the video, but what I'd like to kind of preface quickly before I start, a couple of things. So the video is going to show some online configuration of the HART device. We're going to read HART data, and we're also introducing a new process analog HART process object that's available in PlantPAx. So without further ado, I'll start the video. And video's not starting, so let me try this one more time. Sorry for the delay, folks. I think what I may do is jump over here, and I've got the backup video. So can everybody hear that?
Yeah, you're good.
Sounds good.
Hello and welcome. This video will speak to the newly introduced PlantPAx 5.0 Highly Integrated HART feature. With PlantPAx 5.0 and Highly Integrated HART, we have improved the workflow to integrate HART devices within the new PlantPAx process controller. The software we will be using within this tutorial is FactoryTalk View Studio SE version 12, and this new feature is only available to the new process controllers of the Logix controller family version 33 and above. To begin, I have an open Studio 5000 project connected to a pre-configured process controller. Next, I will navigate to the process controller I/O tree and highlight a HART device with the tag name TI5000. In this example, an Endress Hauser Trust-Sense temperature sensor connected to a new HART analog input module 5094-IF8IH. This allows you to show status, configure the devices, and make online changes to the devices. To demonstrate the new features of the 5094 HART input module and the process objects, I will configure a new HART device within the I/O tree while we are online. To add a new device, right-click on the HART communication bus under the 5094 HART module and select Discover Modules. All connected HART devices will be auto-discovered. You can also add devices manually. Select the device and press Create. As you can see, the module will read the device information, Endress Hauser Delta Pilot M, and the tag name PI4000, automatically via HART communication from the device. We will now edit the module definition by pressing Change next to the connection. We're able to select a PlantPAx data connection. This is a pre-configured data type to match the new PAH, Process Analog HART Embedded Process Object Instruction. Beside the four dynamic HART variables, PV, SV, TV, and QV, users can add additional device variables specific. I will add, for example, an additional sensor temperature variable. Furthermore, users can add additional commands defined via the device's EDD file. Following the configuration, we will press OK on the module definition window. Press Yes on Change Module Definition. Finalize configuration of the module by selecting OK on the new module definition box, along with the general window. Click Yes to create the new module online. Following the configuration of the device, along with additional commands, I would like to highlight the resulting tag structure. Navigate to the controller's tag browser. Search for the device's tag name that was configured, PI4000. Next, expand the tag structure and highlight the device tag name, PI4000 PAX device input table. As you can see, we have three members. These members are utilized within the control strategy along with the analog input and smart device faceplate. The first one is the new PlantPAx data type, along with the additional variables and command that were configured. All these members are then utilized within the process analog input strategy, along with the faceplates. Next, I will navigate to a pre-configured routine that includes the process input strategy. Here, you can see the PAH, process analog HART, instruction tied directly to the PAI, process analog input instruction. What is shown in this function block diagram is the process analog input control strategy that is pre-configured and ready for use via the process object library download. As you can see in the PAH instruction, there is the reference to the PI4000 device input table. This corresponds to the configured device. Lastly, I will highlight the HMI features of Highly Integrated HART. On this display, I have the PAI global object that is tied to our PI4000 PAI control strategy shown in the previous steps. To start, I will click on the global object to launch the PAI faceplate. To access the HART faceplate button, navigate to the Maintenance tab and press the Smart Device Faceplate button. Within the smart device faceplate, there are 3 tabs: Operator, Maintenance, and Diagnostics. Within the Operator tab, we show the HART device's variables and corresponding values along with the device's status. Next tab is the Maintenance tab, which includes the description and the tag of the device. Following that, we will select the Display Advanced Properties navigation button. Within the HMI tab of this window, configuration of the PAH block can be if the user has the correct access level. Select HMI configuration. This gives the user with the proper rights the ability to change the labels, decimal places, etc. Lastly, we will navigate to the diagnostics screen, which shows the device's status along with the active diagnostics. After viewing this video, you should come away with the following information: ease of integration between HART devices and PlantPAx's process objects, along with PlantPAx HART process object HMI features that are included in PlantPAx 5.0. Remember, you'll need FactoryTalk View Studio SE version 12, process controllers of the Logix controller family, version 33 and above, and a 5094 HART enabled input or output module. For more information on the highly integrated HART feature or PlantPAx 5.0, please contact your local Rockwell Automation representative. Thank you.
Okay, well, we want to thank Rockwell for that video, and I'm going to go ahead and get back into my presentation. So a couple of things I'd like to recap on the video. There's a lot in there. Is again the ease of use in the fact that now with PlantPAx 5.0, with the process analog HART process object, we can now get access to all the information, not only the 4 dynamic variables, but also all the other HART pass-through information is now accessible through the configuration of that process analog HART instruction. And also the link between the process analog HART instruction and, in this case, the process analog input instruction, and how those work together in FactoryTalk View SE as part of PlantPAx 5.0. So it's very tightly integrated and I think well named Highly Integrated HART. So hopefully everybody took some things away from that video that are positive. And so to finish, we kind of thought about the couple of maybe frequently asked questions that you may have about Highly Integrated HART. And we want to make sure, we want to emphasize the hardware and software requirements that were in the video, but just make sure, this is the new Flex 5000 HART modules. And to get to those, to get to the process analog HART instruction, you'll need version 33 of Studio 5000. And then with PlantPAx 5.0, you'll need the Logix process controller, as well as View SE version 12, which is all part of PlantPAx 5.0. So that's the first question. The other question we get a lot is especially from our customers is, okay, so with this highly integrated HART, does that now replace my HART handheld device configuration tool? And the answer is we're really not positioning highly integrated HART is to replace the handheld configurators, because they have their place. But what we are saying is it's much easier to do maintenance now on a HART system using these tools that are available in the highly integrated HART solution. So no, we're not telling you to put away your handheld devices. You'll still need those, but please use the new highly integrated HART. And so, so another question may be,
David, this is Justin.
Yeah, you want to say something?
Just to add to that. So we still, your HART communicator is still your good maintenance tool for your doing field support. Enders Hauser Field Care is the tool that we're recommending now that we've removed that feature out of the Asset Center product. So Enders Hauser Field Care would still be that configuration tool that's held online. You also can use, there are some free tools out there like PKware, right? Those are also tools that can use to work on HART devices for free. So yeah, the highly integrated HART is just replacing that kind of onerous 200-page manual you talked about, right? That is to make this process easier. You saw in the video where you could just simply select variables and say okay, and boom, that variable is in your system now. You can also create those instructions where before you had to go through, again, kind of a long process to create those with the 1794 blocks, but now with the 5094 blocks, you don't have to do that. So hopefully they see some value in that. And yeah, just wanted to reiterate that the tools that are still there to work with like DTMs, for example, those are still absolutely, you know, there and in place, and what the way you want to go.
Yep. Yeah.
If there's, by the way, if there's not a device that's in the AOP, so David showed the link to the AOP where you can download it. Today it is a separate AOP because it's quite large, because it has all these DD files in it. So we quite frankly didn't want to make the Studio 5000 download any bigger than it had to be. So we left it separate in case you don't use it. But if you need it, just grab it. It's about 1 gig and toss it into your application. And then if there are any instruments that are not in that list today, there is a tool inside the AOP to add more. So you'd simply go to that vendor's website, grab their EDD file, and you could import it into the AOP. And now you'd have a new instrument. There's also, if you can't find it, there's also a generic EDD file. So you could just use the generic one to kind of get started. Or if there was a device maybe that was either so old or so new that nobody knew about it yet, you could use the generic. So just wanted to pass along those few tidbits.
Okay. Yeah. Great. Thanks, Justin. And so that kind of covers the third FAQ was do I still need message instructions? And that answer is no. So all the tools we talked about today supersede the need for message instructions now on Highly Integrated HART. So with that, I don't know if there's any questions in the queue. I haven't been looking, or if Justin, if you wanted to add anything else before we wrapped up.
I did see there was one comment, you know, about the like sort of who's next. The focus is to go to the 1756 card. I think it's the 16 IF16IH, I believe. So they're looking at that one to move that to highly integrated HART as well. And then of course, any new families of IO that come out after today, you know, the assumption is they would have that feature in them as well.
Okay. Well, great. Well, if that's all, I'd like to thank everybody's attention this morning, and hope you have a great rest of your day. Thank you very much.